Hey guys, thank you and welcome to Dynamic Data Analytics. It is where we make decisions out of data. And today I would like to show you how we are going to analyze COVID-19 data using ARC software. And specifically here, we are going to see how we are going to generate our global map that you can get real-time data. It is really a good visualization that you're going to see. Also, we are going to see how we are going to model COVID-19 using the SIR model. SIR model is a model that normally is used to model infectious diseases such as COVID-19 and among others. So to start, I want to go to, I'm using the ARC Studio. So I have to search for ARC Studio. This here, I open my ARC Studio, get it open first. Then I'm going to type in the script window. This is the script window here. So then we are having the console here, but I'm going to type in the script window. First of all, what you need to do, you need to have the package for COVID-19. It is called COVID-19.analytics package. So for instance, for my case, I already installed in my laptop, but in case you don't have the package, you go to packages here, then you go to install, then you search COVID-19.analytics. Then from there, you can come here and install. But for my case, I already have the package. Then I can go directly and start. First of all, I need to load now. After installing the package, I need to load the package now into my computer. And I hope that most of you are watching this video already have the basics in ARC software. But in case you don't have dynamic data analytics, we do offer, you can always reach out to us and we are going to give the contact at the end of the session. So first of all, I need to load my package. So to load my package, I'm going to use the function library in ARC. So I type library, rather, you see, when you just type, it pops up, then I select. Then from there, I type COVID-19.analytics. You see, it has just popped up because I have already installed the package. Then from there, I can run it. So the library is here, you can see from the console window. Then the next thing now, I want to get the aggregated data uh, on this COVID-19. So let us store our data in an object called AG to refer to aggregated data. And remember, I can even say my data, anything can happen. It's not a must, I use that one. So my data, and then I store. Remember, if you went through the basics of R, you know how it is being stored, the symbol. Then I need COVID. There's an object here called COVID-19.data, not an object, rather it is a function. Then from there, I write case, you see, it has popped up case is equals to, I need an aggregated data. So I'm going to type aggregated, sorry, spelling. Remember, we start with the quotation, opening quotation marks, because the word aggregated is just a string. So that all strings must start with the opening and closing quotation marks. I hope I have written the right aggregated. Okay, thank you. Then from there I can run. So you can see from the console window, let me try to maximize the console window. Sorry, you see reading data from HTTPS row. This is the directory whereby we are getting the data. The data is, it is on a daily report, and it is as at May 9th, 2020. So you can just see here. This is very, very interesting. Then the next thing we need to do now, uh, let us try and view this data. To view the data in R, we have imported, or we have mined from a database. We use the view function, and the view function starts with a capital letter. So view, then you open the bracket and close. Then after that, we run this code. You can use run this code. I can run here. Sorry, invalid first argument. I know I have made a mistake. Oh, sorry. I haven't included the object in which the data that we need to view belongs. So view, open. So the data that we want to view is called my data. It is called my data. Then let me run. So you can see this is the data here. My data. Let me try to. You can see the data. Admin. This is for US. It is a global data, but it starts with the US. You can scroll downwards. You see Yemen, Vietnam, Venezuela, United Kingdom, United Emirates. So this is very interesting. Let me try and minimize the window. Sorry. Okay, let me minimize this one. Okay, the view. Let me root to the code. So this is the console window. Okay, yeah, that's okay. I hope you have seen how we view the data. Then another thing we need now to get the time series data. So the time series data, I want to store it in an object called TSC. So time series data, and the time series data that I need is on COVID-19.data, the function on COVID-19.data, you can see there. Then now, to get the time series, I need the time series of data of all confirmed cases. So I write TS confirmed, TS confirmed. Then TS confirmed. So I think now I can run this one. So you can see the time series data of the confirmed cases. So the next thing, after we have retrieved the time series data of the you see it is data retrieved on 2020, May, or 10th of May rather, at 8:31. It even gives you the time. So the data is from 22nd January 2020 to 9th of May 2020. So the next thing now, I need now to visualize the live map. If I want to get the live map of these of these data, I use I use the function live.map. Then the map, the data. I want the live map of the time series data. So for which we have stored in the object called TSC. TSC. So from there I can run so that I can get the live map. So it is loading. So you can see the live map here. So let me try to zoom. So you see. So you can see the global map. You can see the real-time data. You can see this is very, very interesting. So for instance, I want to look at the map of Kenya. Sorry, this is Somalia, Uganda, Yemen. This is Eritrea, Tanzania. Let me try to, okay, zoom in. Yeah, this is East Africa. So for Kenya, the total confirmed cases as at the last time that this data was collected was 28. 28 new cases. You can see Egypt is here, Sudan, Chad. This is a very, very interactive way of visualizing data. So you can see You can rotate this global map. You can see Japan, Korea, that's South Korea, Taiwan. Then you can see China. So this is very interesting. You can see. So this is one way of visualizing this data. So the last and also the most important thing, you can save this. You can download this plot as an image. At the same time, you can, if you come here, you can, yeah, you can download as an image, or you can save even as any other file format that you need. Then the last thing we need to look at now is there's a model that we do use in modeling infectious diseases such as COVID-19. It is called the SIR model. S stands for susceptible. Susceptible means the total number of people in a population. Like for Kenya, for instance, the population is approximately 47 million. So we assume that all the 47 million people in Kenya are not yet infected, so they are susceptible to get infected. Then from there, we move to infected now. After those are people now who have who have gotten the disease. Then the R stands for recovered. Those are people who have recovered from the disease. So to generate the SR model that is used in modeling infectious diseases, I'm going to use the function generate .si model. So our data, we are going to use the time series data. I'm interested in India. Let me look at India. Then from India now, because you must set up the total population, I'm going to use the function tot.population of India. The total population of India that is susceptible, it is about 3 billion. So let me say 3 billion. That is this 3 billion? Let me confirm to ensure that, yeah, this is 3 billion. Then let me run my command. So it is still running. So you see the arrow maximum of infected. This is about 7.24%. 7.24% of people will be affected. Assuming the maximum number of casualties, assuming 2% fatality rate in India will be 43,000 people, 465. Yeah, so you can see the model, you can be able to predict the number of people that can be affected, the maximum number of people that can be affected, and the maximum number of people that will die. But let me try so that we can see if we can generate, if we can generate, let me run again this model. This is for Kenya. Let me try Kenya or South Africa. Let me try just Kenya. Kenya has a population of about 47 and 47 million. Let me run. So you see in Kenya, maximum of number of people that can be infected is 52%. Maximum number of people that can die, assuming that we have 2% fatality rate, it will be 1,000. and about 43. So maximum days that the 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 epidemic can take in Kenya is 90 days. So it can last up to 30th of June 2020. So thank you for watching our tutorial on how to model COVID-19 data using ARC software. So you can always reach out to us at Dynamic Data Analytics. Also, that is our website, Facebook page. So feel welcomed. We can help you in other form of data analytics. So thank you for taking your time and for being with us until the end of this presentation. Thank you so much and bye. Keep learning so that you can be able to understand very well these things, especially in data visualization and analysis. Thank you.